Good morning to everyone. Today I am going to discussing about introduction about the finite automata and also about the DFA. So what is finite automata? Why it is required means to design the compiler design. These are all the prerequisites to design the compiler design in efficient way. So finite automata is a self processing model to solve any kind of problems in a efficient way. So finite automata will start with the states and the transitions. So each and every state will be read. After taking the states, it will be read some inputs. So after that it will be reach the next state. So from current state to next state will have some transition. For the each and every input can be performed to reach the next state. So for that purpose we have to learn the basic concepts for the finite automata. What are the basic concept of the finite automata? So before going to give a state diagrams and transition, we have to learn the basic concepts. What are the basic concepts? To design a particular finite automata, the string, so the each and every string can be acceptable. So which one is acceptable string, which one is does not acceptable string? For that purpose we have to learn so many basic concepts. So for that purpose the languages are generated, grammars are constructed. For that we have to learn the basic concepts. So what are the basic concepts in a finite automata? So first one is symbols. Symbols are nothing but symbols are nothing but 0, 1, A, B, C. These are all the binary digits and characters. Any characters comes under the symbols. So after that we have to learn alphabets. So alphabets is nothing but collection of symbols. So in these alphabets we are having binary alphabets, means 0, 1. The combination of zeros and ones we can call it as a alphabets. After that A, B, C. These are all small case alphabets. A, B, C. These are all capital alphabets. So after that we have to generate the strings. Strings are nothing but collection of symbols over an alphabets. So the combination of binary alphabet, combination of small case alphabets, capital letter alphabets, we can generate number of strings. We'll see what are the strings can be generated from the given constraint. So before that, in general, normally how the input will be taken, how it will be stored. In general, everything can be stored in the memory. So after that, in a program memory, whatever we are generating the code in the program memory, that will be moving towards to the temporary memory. So in the temporary memory, how the calculations will do, we'll see. So in the program memory we have given x into x, so it will be moved to the temporary memory. So how the temporary memory will be stored? So from given inputs, for example in the place of x we have given 2. So how the calculation will do? 2 into 2 equal to 4. That will be, the 4 will be given as a output. That is nothing but output memory. In general we are doing the calculation like in this way. So in the automata we are having the same process, but finite automata is nothing but finite amount of data. It is not an infinite memory of data. Finite memory of data, that's why we are not using any temporary memory. We are not using any temporary memory in the finite automata. So we have already discussed about the alphabets and symbols. Now, how the strings can be generated from a given alphabets. Strings are nothing but a collection of symbols or an alphabet or input symbols. So, how the string can be performed means, for example, in our input symbol is represented with sigma. So we are giving binary alphabets here, binary alphabets. From the given input symbols, how the strings can be generated? Strings are nothing but finite number of input symbols. So is a combination of, is a collection of input symbols. So how the string can be generated? Let's see. From the given input, how the strings can be generated means 0, 1, 0, 1, 1, 0, 1, 1, later 0, 0. So here in this way the strings can be formed. So here 0, 1 means one occurrence, 0, 1 means two occurrences, 1, 0 means two occurrences, 1, 1 means zero occurrence, 0, 0, 0 means three occurrences. Like this strings can be generated. So here length of the string, generally string is denoted with W. W means word. So the length of the string is denoted with mod W. The length of the string will be denoted with mod W. W is called string. For example, we are taking a string as ABC. What is the length of the string here? Length of the string means ABC. The length of the string is 3. In this way, we are considering the length of the string. Next, empty string. Empty string means a string does not having any symbol. It can be represented with epsilon here. It can be represented with epsilon. Next, these are all some of the operation which are performing on the string. Next, prefix of the string. What is the prefix of the string? For example, earlier we have taken ABC as a string here. So what is the prefix of the string? We'll see. Prefix of the string means, we have taken same example ABC like that. What is the prefix of the string? Including epsilon. A. Prefix symbol means it contains leading symbols A, B, AB and complete string. These are all comes under prefix of the string. Next, proper prefix. What is proper prefix means? Except epsilon, excluding epsilon and complete string, we can consider as a proper prefixing. What is the proper prefixing here? A, B, AB only. This is we can consider as a proper prefix of the string. Next, suffix. Suffix means trailing symbols we are taking. What are the trailing symbols here? For the taking same example ABC, what are the trailing symbols here? Trailing symbols means including epsilon, we are taking the trailing symbols. Epsilon, C, BC and complete string. Next, proper suffix of the string. Proper suffix of the string means we are excluding the epsilon and complete string. What is the string we are generating for the proper suffix of the string? We are excluding epsilon. What is the suffix of this string? C, B, C only. Right? Next. Languages. Next concept is languages. So mainly we are considering two types of operation we are performing on the languages. Here same like that, string length we are taking, length of the string also same like that we are taking, empty string also, substring also we are taking. Substring means a part of the string, a part of the string. Here in the given example A, B, B, A, B, any kind of part of the string we are taking from the given string. So A, B, B, A, B is a string. What is a part of the string? Either A, B or B, B or B, A or A, B. These are all considered as a substring. These are all some operation we are performing on the string, prefix, suffix, like that. Now we are performing mainly two operations. First one is a clean closure. Clean closure we can also called as a star closure. Star closure means including zero occurrences, means epsilon. Including epsilon, many more possibilities, many more strings we can consider in the clean closure. Zero, or we can also call as a zero or more occurrences. That is comes under clean closure. For example, we are taking A star. How we can generate it for this clean closure means, in our language the strings can be generated for this clean closure. We can start with epsilon. Zero or more occurrences will be considerable in a star closure. Epsilon, A, many more A's can be considered. This is we can call it as a clean closure. Next, one more main operation which are performing on a language is positive closure. Positive closure will start from one more occurrences, one or more occurrences. One or more occurrences means, taking same example here, we can represent it with a power plus. A power star means clean closure or star closure. A power plus means positive closure. Positive closure means one or more occurrences. So here A plus means how the strings can be generated in a particular language, how the strings can be generated for the A positive closure. We can start with A, single A, double A, triple A, like that all the string, remaining all the string can be generated for the positive closure. So in this way we are performing these star closure and positive closure operation on the language. So here pi is nothing but a null set of size, set size we can call it as a mod pi. Set size means we can, how the length can be denoted for this set, we can represent it in this way. Next, lambda, string length. Set size is different, string length is different. So modular lambda is nothing but 0. So infinite language is nothing but infinite numbers can be generated. So operation on a language, union operation, intersection operation and minus operation. Union operation means all are presented in the first set and second set we can combine together. Intersection means common term which are taking. So minus means what are the common terms, other than that we are taking the remaining terms. Reverse of a string. For example, we are taking AB. Reverse of a string is BA. Like that we are representing reverse of a string. Concatenation operation. Here we are having two sets, A, AB, BA, BB, B, comma, AA. So here concatenation operation means, so in a first set we can concatenate it with second set. So from the given first set A is concatenated with second set B. So after that A is concatenated with, in a second set, second string A. Similarly, remaining strings also concatenated with the second set. In this way, then concatenation operation is performing. Next, DFA. So here, before going to DFA, what is DFA, how it is related to the finite automata? So in the finite automata, we are having two types. So without output, with output. Without output, we are considering mainly two types. First one is DFA, second one is NFA. So in the finite automata we are considering deterministic finite automata, and also second one is non-deterministic finite automata. So what is the DFA? We'll see. So how the DFA will be constructed, how the transition will be performing. So for that purpose we have having three steps. First one is state diagram. State diagram is also called as transition diagram. Second one is transition table. Third one, transition function, also called mapping function. With the help of three, we can generate a deterministic finite automata. Let's see how the state diagram can be constructed. So here we are having the state diagram. So in the state diagram, circle is represented with all the states, and arrows are represented as transition. The given alphabets are nothing but input symbols, A, B, C, like that. So initial state will consider as a arrowhead. So here how the state diagram can be generated is, first we have to know the mathematical representation of the DFA. What is the mathematical representation of the DFA is? What is the mathematical representation of DFA? Before going to draw this state diagram, we have to know the mathematical representation of the DFA. What is the mathematical representation? To construct a DFA diagram, we have 5 tuples. What are the 5 tuples? 5 tuples. What are the 5 tuples? Sigma, Q, mapping function, Q naught, F. Sigma is nothing but whatever we are performing as a input symbols, all are considered as all are represented with sigma. So here we are taking in this diagram AB symbols. AB symbols are the inputs. These input symbols are represented with sigma. Q is nothing but set of states will be represented with Q. So here delta means mapping function. How the mapping? Here by seeing this diagram, what are all the sets? Q0, Q1, Q2, Q3 and Q4. These are all the states will be represented with Q. Delta is a mapping function. So how the mapping function can be performed here? Q state, Q means state, is mapping with input symbols will be reached to another state. From current state to next state we have mapping with input symbols. Q0 is a initial state. Q0 is a initial state. F is a final state. F is a final state. Based on these 5 tuples we can construct a DFA diagram. So first in the input tape, so here in the input table A, B, B, A symbols are there. First in the input tape all symbols can be read and will be stored into a finite control machine. In the finite control machines all the states can be represented. So how the symbols can be acceptable from initial state? Initial state we are taking as a Q0 here. How the initial state can be generated, how the transition can be moved from the current state to next state. So here DFA means, so we are having only one path for a specific input from current state to next state. So we are having only one path, that is nothing but only one transition for this specific input from one state to another state. We are having only one. For example, we are having 2 symbols A and B. So A is A transition and B transition. Both transition can be generated from a specific state, and for this same input we are not going to generate another transition for the same state. That is the condition for the DFA. So from the particular state we are not giving many more transition for the specific input. That is a constraint for the DFA. So in this way the diagram will be generated. So from Q0 state to Q1 state a transition is generated. After that Q3 to B, where the B is reaching. B is going to Q5 and A is reached to final state. So how we can identify the final state means which variable is generated with a double circle. That state we can consider as a final state. See the another example. Q0 on A will be reached to Q0 only. So Q0 on B will reach it to final state. So the string can be acceptable. From the given string AAB, it will be reached to final state. Q0 on B is reached to Q1 state. So that will be acceptable state. So how the string can be rejected? We'll see. First, Q0 on B will reach to final state as a Q1. Next, from the Q1 to A is reached to Q2 state, and Q2 on B will reach to the same state, but it is not a final state. That's why that string is rejected. In this way, the DFA is going to constructed. See the transition table. Here Q0 on A is moving to Q1 state, Q0 on B is moving to Q5 state. Similarly, remaining all state will be having the transition from A and B input. In this way, transition table can be generated. By taking one more example, ABBA. ABBA. For example, we are taking ABBA, how the DFA diagram can be considerable. So ABBA. ABBA means from Q0 state it is going to Q1 and Q1 to B. So Q1 to B it will be reached to Q2, Q2 to B it will be reached to Q3, and from a given string A also there, Q3 to A it will be reached to Q4. In this way the string can be acceptable from the given string ABBA. So by taking more example, it will be completely based on the given constraint. For example, the given constraint, the string should be started with 0. So in our input symbol 0, 1 and 1. What is our constraint? The string should be started with 0. Started with 0 is a constraint. Based on the constraint, the DFA is generated. So what is a string means here? The DFA diagram is started with 0 only. So initial state Q0, starting with 0 means we have to give the 0 only. So 0 and next state Q1. Starting with 0 means there is no constraint for final state or end state. That's why we can able to give 1 here. So what is our constraint? Starting only. So from a particular state 0 input is there, but 1 input not is there from the Q0. That's why we have to take the dead state or trap state. What is the rule for dead state or trap state? Means it cannot be returned back to the final state. It cannot be returned back to the final state. So for this also we are having 2 inputs. In this way the DFA is constructed. Thank you.